make one last comment about the Lagrangian approach, which I probably should have made at the outset. And it's actually sort of obvious if you look at the Lagrangian approach, but I should have made it explicitly. And that is this. The Lagrangian approach works for conservative systems. If you've got dissipative forces in the system, the Lagrangian approach is not going to be a good choice. There are some cases where it's possible to actually incorporate dissipative forces, in particular if you can actually ignore the dissipative force when you start out. Like, so for example, say you've got friction in the system. If you can set up the problem to ignore the dissipative force initially, solve the problem using the Lagrangian approach, and assuming it's conservative, and then add the dissipative force in later, that's fine. You can make that work in a lot of cases. But in general, if you look at the Lagrangian, right, Lagrangian is the kinetic energy minus the potential energy, right? This approach is one that assumes that the system conserves energy. So don't try to use the Lagrangian for systems where you're not conserving energy. It doesn't make sense to do that. You can certainly get there using the Lagrangian, but you need to be much more careful about how you do that. And the approach that you use for non-conservative systems is typically to sort of solve it as a conservative system first. Right? When you solve it without dissipation, like when you turn friction off or you turn drag off, what that will give you is some equations of motion. And then it's often the case that once you have those equations of motion without dissipation, you can actually add additional terms into the equations of motion to account for the dissipation. So it's sort of using a Lagrangian, then use F equals ma to add the dissipation. And I just wanted to sort of highlight that idea. There's more that you could talk about here, but at a high level, you shouldn't be using the Lagrangian unless you're dealing with a conservative system, because the formulation of it depends on this idea that it makes sense to write a potential energy for the system. And when you've got dissipation in the system, it really doesn't make sense to write a potential energy for the system.